So let me remind you what is one-to-one function mean. A one-to-one function, first of all, there's domain and range swap, right? If you know the domain and range of one function, you can figure out its inverse. All you do is just swap them. And the graph of exponent, I don't want to go in here yet. So let me remind you, let's recall one-to-one function, one-to-one function, domain and range are swap. The graph symmetric about the line y equal x. And then to verify if two functions are inverse, you can remember what the process? We put one function into another, right? And then do the same thing to the other way. And so if f of g of x equal to g of f of x is gonna be x. Remember that part, it's really important later for when you solve a log. All right, so that's one-to-one function we call. For exponential function, it has the form, I know the general form is much more complicated, but let me write the general form. General form of exponential function is y equal a times b to the h, to the h minus h plus k. But just hang that for now, okay? We're gonna talk about y equal b to the x, right? The simplest one, the basic form. Is this a one-to-one function? I mean, yes, they told you it is, but imagine they don't say anything. Would you know? Because yeah, it passed the Hannah's-Online test, right? You don't have to wait for them to tell you once you have the graph. It is one-to-one function because it passed the Hannah's-Online test, and because it's one-to-one, it's gonna have the inverse and vice versa. If you are have inverse, you are one-to-one. So I start out now. How do I find the inverse? Do you guys remember the process? Find the inverse. The first step is replace f of x with y, which I did here. Y equal b to the x, and then the second step you swap x and y. So x equal b to the y. Now, usually we solve for y with no problem. However, the problem here is why the variable you want to solve is in the power. Right? So how do we bring it down? Well, log is the inverse function of the exponential function. So if I would have take log base b both sides, like this, log base b of x, y is base b, I'll tell you later, equal log base b of b to the y. It's kind of like taking square root both sides, kind of like that. Just log base b. The logs base b and the b to the y. Remember what I wrote up here, because log and exponential are inverse of one another. When you put one function into another, they cancel, right? What's left over is the letter x. In this case, it will be the letter y, right? That's the property come from. That's why I'm able to cancel log base b and the base b. And that's the reason why I'm taking log base b, not log base a, not log base c. We have to have the same base. So this implies log base b of x equal y. Equal y. And that is the inverse function. And this is the inverse function. And y, you replace y with f inverse of x. Remember that? So that is the inverse function of the exponential function. Too pretty. Sorry, not too pretty. And what is the f of x? F of x is this guy. That's f of x, right? That's f of x. And that's f inverse of x. No, it's not. It's they kind of related to each other because they're inverse, but it's not. What sheet? Oh, it's not this one? Uh-oh. Give me a second. Oh, okay. How did I do that? I don't want to touch it. All right, you should hear me now. So log base e is equivalent to ln. So if I would have x in front of log like that. It's called the argument. Then all I have to do is put the x in front of ln. Right? So log base e of x is the same thing as ln x. If I don't write any base at all, it's going to be understood as base 10. Right? They call that a common log. So I'm sure you all know that from 662. All right, now we're going to convert from log to exponential and vice versa. The one thing I want you to remember is that log, if you would have forget everything that I just said, but at least you remember this. Log equal exponent. If you could remember this and understand why this is, you would have solved 80% of the log problem. Of course, you have to remember other transformation too, but this is the most important thing. And why that is, let me show you why I say that. Remember, you start out, when you try to solve for y, x equal b to the y. Y is what? Y is the exponent, right? What happened at the end when you transformed it? Now log equal y, log equal exponents, right? So that's why I say log equal exponents. And it would help you transform between log and exponential. Let's do number one first, convert to exponential form, meaning they want this. They want y equal, or no, not y equal, yeah, they want y equal b to the x, right? This exponential. What is the base here? If you look at the, yeah, 5, log base 5, right? So the base is gonna be 5. Remember what I say, log equal exponent. So number 2 is the exponent. Square. Well, the only thing you have left is 25. 5 squared equal 25 makes sense. Another way you can do this, alternatively, if I was you, I wrote too big. Move my answer. That's my answer. I'm gonna move it to the right a little bit. Like that. Another way is I do this. I don't want my log to be on the right side. You know how you don't like your x or your y to be on the right side. I'm just gonna rewrite it. Log base 5 of 25 equal 2. It's the same thing, right? And then I'm gonna use what I call the tornado arrow. 5 squared equal 25. Base to the power equal the argument. When I say argument, I meant the number in front of log. Did you get Phi squared over 25. Same thing right here. I do the tornado arrow. Phi to the 1/2 equal root phi. Is this true? Is phi to the 1/2 the same thing as root phi? Yes. Yes. That's another way of learning it. C, I would rewrite C if you know if it confuses you somehow. Log base phi of 1/125. I have a habit of put a parenthesis around my argument just to distinguish from the base. And please write the base like a subscript. Right? Don't write like same line. Or -3. You do that little arrow thing. Phi to the -3 equal 1/25. Is it true? Is it true? Yes, you can check. Don't write this down. You don't have to. Phi to the -3, I can rewrite it 5/1 to the -3. Is that okay? Like that. Remember when you get rid of the negative exponent, what do? You flip, right? So it'll be 1/5 to the third. Well, 1/3 is still 1. Phi q is 125. So yes, it's true. I explained. What about D? Can someone tell me what D is? Equal 1000, right? So I would write that because it's a common log. They don't write the base, but I will here. So 10 cubed equal 1000. It's an arrow help. Unless you remember on the exam. And where do I start? We'll start at the base and just do that little tornado arrow. ln 5 equal A. ln, like I said, ln equivalent to log base E. All right, so I'm going to rewrite ln as log base E. And then put the number 5 in front of it. Put a parenthesis there just to know that it's the argument. Equal A. E to the A equal 5. So this equivalent E to the A equal 5. And there's no way we can check this because those are letters. But we know it's right. Remember, log equal exponents, right? A is the exponents. It should be on the exponent position, right? B, E, the base. And then we got it right. Right? F is your U-1B. Let me tell you, I'm sorry, you try 1A. So you try 1A. And let me tell you, you try 1B right now, so I don't forget. Try 1B right here, C, 2C. All right, let's now convert from log to exponent. And we're gonna use that thing, log equal exponent. So here they want log base B equal log base B of x equal y, right? Something like that. They want log, right? So so first thing first, you write out log because log function. Equal what? What should I put on the right hand side? I'm gonna fill up something on the left hand side too, but right now, what can I put on the right hand side? 3, right? Because I said log equal exponent, and 3 is the exponent. 3, and then you fill them in. 2 is the base, so gonna be the subscript 2 here, and then A will be your argument. There's nowhere we can go. It makes sense. You can check, right? 2q equal 8. You can check. You gotta tell me what you got for B. You can just fill in one thing at a time. I don't think all of it at once. Log equal, as you can see, log equal what should I put on the right hand side? 1/4, right? 1/4. Thank you. 1/4. And then base is the 13, yeah. And then the argument is the 4 root of 13. Sorry, it's small. It's quite difficult to see. Makes sense, right? If you do a little arrow, it makes sense. 13 to the 1/4 is same thing as root 4 to the 13 of the 13. Log base, oh, this one you can just do log base 10 equal to, and then the argument would be 100. 10 squared. Log here is base is the e, right? And then the exponent is 5, so on the right hand side, and the b is gonna be here. B is gonna be the argument. And then last one, someone read it for, oh, but by the way, this one I can rewrite it as this here, or because it's ln, I can rewrite it as what? Ln b, right? Equal 5. This ln base e the same thing. I'm sorry, log base e the same thing as ln b. I'll take both answer. I like ln because it's short, but if you're not accustomed to it, you don't have to use it. Just by log base e. All right, last one. Log base 10, right? Exponent is x, so the argument is gonna be e. Makes sense. 10 to the x equal e. So you are comfortable with changing between log and exponential? Yeah. Okay, so we agree that if I were to call f of x is b to the x, then the inverse of f of x will be f inverse is equal to log base b of x. And again, we know that they swap domain and chain. I'm sorry, domain and range. So if you look at number 3, they make a table for us already, so which is good. If I plug in -3 into x, 2 to the -3 is 1/2 cubed, which is 1/8. Now, if you're not allowed to use the graphing calculator, it's easier for you to make a table for the exponential function and then swap the domain and range instead of, go straight to the log table. Because if I were to say log base 2 of 3, how would you know what is log base 2 of 3? Unless your calculator have a different base other than 10 and e. I think your calculator only have base 10 and base e, right? Yeah, you don't have other base, which is bummer. So it's easier to do the exponential table, and then all you do is just swap the x and y if you want to look for log. All right, so they did the table for us. They graphed the exponential function for us also. Now our job is to graph the log. So x is 1/8, y is -3. Right here, really close to the y-axis. X is 1/4, so it's a quarter. Y is -2. Right there, just slightly further out. X is 1/2, y is -1. You know, my dot is just really out of order. Yeah, that. Yeah. Okay, better. X is guess what? X 1, y 0, right? You black for that one. This is 0, 1, and this one is 1, 0. Are they important too? Because you're gonna use that to transform your function. X is 2, y is 1, 2, 1. X is 4, y is 2. X is 8, y is 3. If I graph wrong, let me know, okay? Do not cross the y-axis. Kind of like the exponential, we don't cross the x-axis. I know it look like I'm touching it, but in reality, I should not be touching it. But then it's so close, it looks like touching it. Now, what do you see? What kind of graph, what kind of exponential function you see here? What do we call it? Do you remember last time? Exponential growth, right? Exponential growth. So it's increasing from left to right. See, look, from left to right, it's getting higher and higher. Same thing here. Exponential increase, log also increase, right? It's increase from left to right. Of course, it's gonna go higher and higher. Let me write a little note here. I see increase in trend for both graph. And again, the swapping x and y. Let's do the right one. X is 8, y is -3. X is 8, y is -3 right there. X is 4, y is -2. X is 4, y is -2. X is 2, y is -1. X is 1, y is 0. Then use black. 1, 1, 0. X is 1/2, y is 1. X is 1/2, y is 1. Right there. X is 1/4, y is 2. And 1/8, 3. To get close to the y-axis, as usual. Sure, like that. What do you see the trend here? For the exponential, it's exponential decay, right? It's decreasing from left to right. It's get flatter to the right. Same thing with the log, right? It's decreasing from left to right. It start high, it's go low. The reason being because of the base, right? On the left side here, the base is bigger than 1, right? So you have increasing graph. Here the base is not less than 1, but it's between 0 and 1. Remember, we don't take negative number for negative base or 1 for that matter. From here we see decreasing trend. Let's answer some questions. Use a graph to fill the following properties of log function. If you look at the red graph, can you tell me what's the domain of the red graph? Both of them. Where does it start? Where does it end? No. Domain, not range, domain. Domain means x values. Do I see it cross the left side of the y-axis? No, right? So it's gonna start at the positive x. Right? So it starts from here, which is this half, the positive half of x to infinity. Right? So it starts from 0, not include 0. I know it looks like we're touching it. On the exam, it's 5 for you to touch it, but if you crossed it, I'll take your point off. But don't cross the vertical asymptote. By the way, that's called the vertical asymptote. x equals 0 or y-axis, as opposed to y equals 0 for the horizontal asymptote for the other graph. These kind of swap. What is the range? Where does it, from bottom top, where does it go? Where does it end? Where does it start? Where does it end? Start from negative infinity, right? And it's end as negative, as positive infinity. Do we have the x-intercept? Do we have x-intercept for both graphs? Yes, right? 1, 0. Is there a y-intercept? No, at least not in this graph, right? Later you're gonna see they transform and you're gonna see they cut, but for the basic graph, there's no y-intercept. What is a vertical asymptote? I just said it earlier. Yeah, x equals 0, right? You're gonna say x equals 0. And then for the, let me use red. Is there a horizontal asymptote? No, no. Does not exist. Notice that the domain of log is a positive number only. What does that mean? That means the argument, I would write y equal log base b of capital X. Why do I say capital X? The argument doesn't have to be the little x all the time, right? It could be an expression, it could be x plus 1, it could be 2x minus 3, something like that, something more complicated, right? And I call that the argument. If you look at the graph, the argument is your input. The input is has to be positive. So if I were to ask you to find the domain of log, all you have to do is what? You set the argument greater than 0 and solve. Right? Kind of like square root. It's not negative, but it's more strict because it's exclusively positive, right? Doesn't even take 0. So log of negative and log of 0 is undefined. Where h of x, let me highlight in yellow here, h of x. Maybe I'll do green. Well, h of x, that little big x right there. I wrote. Let me put h of x so you're not confused. Here, h of x represent a function. H of x is called the argument. And when you find the domain, all you have to do is you set the argument greater than 0 and solve. All right, let's solve for log equation. It's hard to solve a log equation, but I know how to solve for exponential function, right? So what I'm going to do, I'm going to transform that equation to exponential function. Do you remember how do we transform that? Using the tornado arrow, right? So x to the second equal 36. So far so good? X to the second equal 36. Right? Transform to x exponent. Take square root both sides. Plus minus x equal plus minus 6. Am I done here? This imply equal I have x either equal positive 6 or x equal negative 6. Well, the positive 6 is okay, right? If it's positive, then it's okay. Can I take negative base? No, right? Remember we talked about the base, either between 0 and 1 or greater than 1. That's for extraneous solution. So your only solution is x equals 6. So when you solve and the x is for the base, you gotta be careful. Okay? C is going to try 2. Let's do D. Before I do D, I would do something like this. 4 times log base E. Right? I like to rewrite ln as log base E. At least for the sake of your understanding. I'll ease you into using ln. Before we transform, I gotta isolate the log. You kind of like isolate square root before you square both sides, kind of like that. Divide both sides by 4. So I have log base E. The argument is 3x minus 4 equal to, and then you use your little tornado arrow. E to the square equal the argument. Don't be afraid. E squared is just a fancy constant. Look in your calculator to tell you where it is. We're not gonna approximate this because they want the answer in the exact form. So we just go ahead and add 4 both sides. So E squared plus 4 equal 3 to the 3x. Divide both sides by 3. X equal E squared plus 4 divided by 3. Since they want exact form, we leave it like that. So far, so good. This is simple. There's many types of solving log. Later, so right now I have log on the left hand side and then the number on the right hand side. All you do is just transform to exponential. Later, you're gonna see more complicated log equation. Right? You have 2, 3 logs right? On the left, and then you have another log on the right. Don't be afraid. I'll show you techniques to solve for that. So that's solving logs. Next, we're gonna evaluate. If I would have give you log 10 like that, and I want you to tell me what is it equal to without using calculator, how would you do that? Well, for me, the first thing I do, I'm gonna let it equal to x. And then I'll do that little tornado arrow, right? This is log base 10. 10 to the x equal 10. 10 to the what power equal 10? 1, right? So x is gonna be 1. You don't even have to put that x there. You don't want to. Just put the 1 there, right? So x must be 1. By the way, the only time you transform the expression into equation is this time, okay? But don't do that on the exam. If I give you, say, don't write this down. Say 3x plus 1 over 6x plus 2, and I want you to simplify this. Please don't make it into equation. All you do is just factor out the 3 here and then, simplify, right? But the only time we make it into equation is this type, right? The rest do not do that. Log, I'm gonna rewrite it as let me rewrite this in black. Ln is the same thing as log base E, and then bring down the argument E there. E to the what power equal E? That's how you ask yourself, E to the what power equal E? E to the first, right? E to the first. So either you can put 1 there or you can put x here, and then later you say x must be 1. From those rules, do you notice that if I would have log base B of B is equal to 1? B to the 1 equal B. As soon as you have log base B and then the same argument B, you cancel it. Remember, you cancel it. Remember that? I told you to cancel Obviously, they are inverse. Or another way you can think of it is a tornado arrow, right? There's many ways to think of this. As long as your logic is tied together, I mean, you do it right. We're gonna talk about this later, so I'm gonna box it right now, but we'll see that later. For part D, we're gonna rewrite it as log base e, that's ln, and then bring down the argument, which is e to the 4. Later, if you're really good at this, all you do is just tell me that you cancel those and then equal 4, or you can let it equal to x. And you do a little arrow, e to the x equal e squared. X must be 2. The equation x must be 2. This one I'm going to rewrite it as log base 10 of 1 over, I don't know what you write, 100 cube. By the way, here, side work, 100 is the same thing as, can I write 100 as 10 squared? Yeah. And then there's a 3 outside, the 3 outside for the exponent. 2 times 3 is 6, so 10 to the 6. It's a million. I'm going to write 10 to the 6 here. That equal to x. 10 to the x equal 1 over 10 to the 6. 10 to the x equal 1 over 10 to the 6. How do I rewrite 1 over 10 to the 6? Because I don't like the fraction. I want it to be the same base as the 10 so I can, let the exponent equal to each other. Yeah, -6, right? So this equivalent to rewrite the left-hand side. The right-hand side is 10 to the -6. I know it's wrong to say like you cancel like that, but intuitively, it's just how you do it. Okay? Don't say cancel further. It's wrong how to say it. You tell me that I taught you that. Whatever help you remember things, I will tell you. In part what? B? D? Oh, 4. I'm sorry. I'm sorry. I think I erased one of the. Yeah, it should be 4. Should be 4. So 4. Thank you. Yeah, I erased a little vertical thing for the 4, so I thought it was a 2. These are easy. That's why I go kind of quick. All right, ln rewrite it at log base e. Can somebody combine e to the 5th times e to the 8th for me? If I have a to the m times a to the n equal to a to the n plus n. So you add them together, right? You have the same base, you add. So e to the 13. As opposed to, let me write another rule for you. If I have a to the m, and then I raise to another power n, is multiply. You see the difference? You have two same bases, you add the exponents. You have one base and 2 powers, you multiply the powers. So be careful. Can someone tell me what is equal to without even doing anything? If you to tell me you do that, you cancel the log base e, it's good enough for me in the future. And you only allowed to do that when what? You have the same base, right? If I have log base 10 and then e to the 13, I'm not allowed to do that. Okay, so here is a transformation for number 7. They have 3 parts here, A, B, C. I'll explain it to you. I'll explain to you one step at a time. So say I start out with this function, f of x or y equal 3 times log of x minus 1. It's going to be log base 10 here. How do I graph this? Well, you're going to start out with the basic log, right? The parent graph, which is y equal log of x. And then you plug in some point. You plug in some point, say 1 log base 10 of 1 is 0. Makes sense, right? Don't write this down. Log base 10 of 1. Well, 10 to the what power give you 1? 0. Right? You agree? Yeah, right. So that's why they have 0 there. Right? That's how they do it. You know, I'll leave it like that. But you use your calculator, okay? You have log base 10, your calculator. You plug in 2, it's become 0.3. You plug in 7, become 0.85. And then you're gonna do the horizontal transformations. You gotta remember horizontal, reflection, vertical, what they call it, stretch. Vertical stretch or vertical compression, and then the vertical shift is last. So this is horizontal shift. Shift right or shift left? Right, right. FYI, I gotta tell you the general form for log. Y equal a times log of x minus h plus k. So x minus h, because it's a minus 1, you're gonna actually move to the right, right? Because this is h is 1, that's why you move to the right. You move to the right, meaning you're changing the x or y coordinate. X, right? You move left, right, that's x, right? So that means everything add 1 to x. So 1 become 2, 2 become 3, 7 become 8. Right? And then the vertical stretch, it's gonna grow faster, right? Because it's a positive. A is bigger than 1, not between 0 and 1. You're gonna stretch in y or x? Y, right? So you get longer, right? That's y. So everything for the y component is gonna multiply by 3. Well, 0 times 3 is still 0. 0.3 times 3, 0.9, and 0.85 times 3 is 2.55. So you do the same thing you've been doing. So far, so good. And then they graph. Well, they graph step by step. Maybe we don't have to do that. It's a real test. Not step by step, but you will graph eventually. The next step, I'm going to find the inverse of that log function. The same step apply. You're going to replace f of x with y. And then swap x and y. And then now you solve for y. And how do we solve for this? Remember the tornado arrow? Remember you from log to exponential, you're going to do the tornado arrow, right? So if I was you, I would rewrite this like this. I like my log to be on the left. Log base 10 of y minus 1 equal x over 3. By the way, before you transform, you're going to isolate the log, right? Isolate the log. Kind of like you isolate the square root. And then the tornado arrow, 10 to the x over 3 equal the argument 10 to the x over 3 equal y minus 1. Add 1 both sides, and then you solve for y. And that y is your f inverse. Right? This is exponential. Right? So this is the inverse of that one, the original one. And vice versa. Doesn't matter which one it is, depends how you define it. And then you graph. I'll tell you the trick. Once you have the exponential, don't make a table again. Don't do the table again. You waste your time. You already did. Right here. All you do is what? Swap x and y, right? Here's y and y. Don't do it again, right? I'll explain this part later when I go to the example. Right, let's do number 8. It's the same thing. First, I'm gonna find the domain of the function. You can remember how to find the domain. You set what greater than 0? You set the argument. Right? The argument is just x plus 2. Whatever inside the parenthesis, that's your argument. And greater than 0, and then you solve. And then you will ask to write in interval notation. So from -2 to infinity. So far, so good. Vertical asymptote. You're gonna set the argument equal to 0. So VA, vertical asymptote. You're gonna set x plus 2 equals 0. Always. You always set that argument equals to 0. And then solve. X equals -2. That'll be your vertical asymptote. And then part B, you're gonna do that little table thing, doing a translation. Pick some point. The parent graph, because you start out with ln, so the parent graph would be ln x or log base e of x. Let's pick some point. If I was you, the first point I pick would be 1, 0. Ln of 1 is 0. Makes sense. I'll pick another point. Maybe I'll pick another 2 point. 3 comma ln 3. I'll pick 3 for x and plug in 3. I got ln 3 for y. Let me tell you the happy ending. What's ln 3 equal to? 3 is 1.1. Decimal, so you know what it is. I'll pick another point. Say 5 comma ln 5 or 5 comma 1.6. What kind of translation I'm doing next? Horizontal or horizontal, right? The first thing first, horizontal. So horizontal translation. That means I have y equal ln of x plus 2. Everything move left, right? Gonna be move left 2. So everything on the x coordinate, you subtract 2. So 1 minus 2, -1. And then the y coordinate stay the same. Let me rewrite the y coordinate. 1.1, 1.6. 3 subtract 2 is 1. And then 5 subtract 2 is 3. Next is gonna be vertical straight.